All right, welcome, boys. So in this video, we're going to be talking about atoms. What I want us to be able to do by the end of this video is I want you to describe how the subatomic particles affect the charge of an atom overall, and I want you to be able to tell me about the relationship between the atomic mass on the periodic table and the a number of protons and neutrons in an atom. Okay. Now, I think that those objectives sounded really high flying and confusing, but they're pretty easy to understand, and I'll explain why. Okay. All right. So let's just quickly recap. This is an atom. In the center is the nucleus. Okay. And then around the side of these things orbiting around, they're called electrons, and they buzz around the nucleus, which is in the middle. And there are two things in the middle: a proton and a neutron. Now, there's something I didn't explain previously. An electron has this minus symbol in it, and the proton has this plus symbol in it. Okay, so that just means that protons are positive, electrons are negative, and neutrons, which don't have anything, are neutral, meaning they're not positive or negative. Okay, so what do I mean by positive and negative? Okay, positive and negative describe their charges, and that's really as simple as it gets. I know you like, but I don't know what a charge is. Think of it like a magnet, a positive and negative. Okay, if you take a negative and a positive, they go together. If you take a positive and a positive, they go apart. Okay, like two sides of a magnet. Okay, but all you need to understand is if an atom is positive and another atom is positive, they repel each other, or they push each other away. And if one atom is negative and the other one is negative, or the other one is positive, they attract each other. Okay. Um, this is what happens with static electricity. When you touch something, you get a shock. What's happened is the atoms in your body have become positively charged. So they have more of these protons in them than electrons. And what happens is when you touch something else that has more electrons, those electrons jump across from you and give you a shock. Okay. All right. So let's go into it. All you need to know right now is that there is the center bit in an atom that's called the nucleus. It's made up of positive protons, neutral neutrons, and on around the outside are negative electrons. Okay, let's get going. Here's protons are blue here, neutrons are red, electrons are grayish black. Okay, all right. So when an atom has a neutral charge, it has the same amount of electrons as protons. So every positive proton there is an equal number of electrons, and they cancel each other out, meaning that atom is what we call neutral. It has no charge. It's not positive or negative, okay? So we can call that normal. It's just standard, okay? It has the same amount of electrons as protons. So it has no charge, okay? It's not going to attract or repel other atoms, okay? If there are more protons, if we were able to get more protons here than electrons, then we would say this atom is positively charged. So that's what happens when you get a shock, is your body becomes positively charged. So it has more protons than electrons. The electrons have left you when you rub against something else, and what that causes is you to be positively charged. So when you touch something, you get a shock. And if there are more electrons than protons, the atom is negatively charged. Okay, we'll play around a bit with this. We might do some static electricity demonstrations when you guys are back at school. But for now, protons are positive, electrons are negative. If an atom is positive, it means it has more protons. If it is negative, it means it has more electrons. All right, that's it for positive and negative. Let's jump on to the periodic table, okay? So what you'll notice, or what you will have noticed in that deductive reasoning activity, if you've done it already, is that the atomic mass is almost double the atomic number. This is because half of the mass is made up of protons and the other half is made up of neutrons. And there are mostly similar amounts of neutrons and protons. Now, that might seem confusing to you. So we're going to look at a periodic table, and I'm going to explain it to you while looking at the periodic table, which may help. All right, so here we have a periodic table. And what I want you to know is that number at the top is the atomic number. And that number over here is the atomic mass, okay? Here it is 13. Here it is 26.981538.6, okay? It's a really long number, quite confusing, but I just want you to know what we're looking at. Okay, so let's take a look at, can I zoom in here? Yes, I can. Okay, let's look at hydrogen first, okay? Hydrogen has an atomic number of 1, which means it has 1 proton, okay? And it has an atomic mass of 1.008, okay? let's ignore the numbers after the decimal point. We're just going to look at the first one, okay? So an atomic number of 1, an atomic mass of 1. Okay, so let's get to ones that'll make a bit more sense than that. Here we have lithium, okay? Lithium has an atomic number of 3, which means it has 3 protons, but it has an atomic mass of 6. Remember, we're ignoring the numbers after the decimal point for now, okay? You'll learn in high school why it has those funny numbers. But what that's saying is it has an atomic mass of 6 because 3 of that comes from the number of protons. The other 3 comes from the number of neutrons, okay? Because there's usually the same amount of neutrons and protons, okay? Let's look at magnesium over here. So magnesium has an atomic number of 12, and it has an atomic mass of 24, okay? Because 12 protons, that's what the atomic number means, and then 24 tells us 12 of that is made up of protons, the rest of it is made up of neutrons. So here we have 12 protons and 12 neutrons. So what that means is we have the same amount. We have 12 neutrons, 12 protons, so we have an atomic mass of 24. All right, we're going to do one more. Quickly let's go calcium. I'll tell you calcium. Let me block it off. There we go. The calcium has an atomic number of 20. Take a moment and quickly tell me if you can figure out. I want you to be able to answer, what does it mean for calcium to have an atomic number of 20? What does it tell us? And what do you think the atomic mass will be? Go. All right. So hopefully you said 20 means it has 20 protons, and an atomic mass of 40 means that it has 20 protons and 20 neutrons. All right. So that's everything for now. You should be able to explain the subatomic particles, positive and negative, how an atom can have a positive charge or a negative charge, and you should be able to explain what the relationship is between the atomic number and the average atomic mass, which tells us that the atomic number tells us how many protons, and the average atomic mass tells us how many protons and neutrons together, and the atomic number is usually half the mass. All right, we can spend some time talking about this. I know it's tricky. It does take a bit of time, and you're going to learn it more in high school, but right now I want you guys to feel comfortable with it. So when you get to high school, it's not a problem. All right, fantastic. Have a great day, boys.